This is AP Calculus 8.3, using accumulation functions and definite integrals in applied contexts. And what we're going to do is we're going to think about definite integrals and how they can help us solve problems when maybe we have the rate of change of something and then one endpoint, but they ask us to find the other endpoint. We can plug into a specific formula to be able to do that. The integral from a to b of f prime of x dx. When we take that integral, wouldn't we have f of x after we've integrated? And then once we find that function, wouldn't we plug b into the f function and then subtract what we get when we plug a into the f function? So basically, this is the definition of a definite integral. That's the fundamental theorem of calculus. And so if you think about it this way, as that being the fundamental theorem of calculus and how you would solve definite integrals, well, then couldn't we, if we wanted to find the second endpoint and we were given one of the other endpoints and the rate of change, couldn't we just manipulate this equation and get the second endpoint alone on one side and then these two together on one side? If we did that, f of a, if I move f of a to this side, wouldn't it be an f of a plus the integral of from a to b of f prime of x dx, which is what we have right here. So by manipulating this, we have a way to find one endpoint when we've been given the rate of change and the other endpoint. And so we're just going to use this information to help us come up with a way to solve some problems. Just to recap again from the last section that we did, remember this is your net rate of change or your net change. This would be one endpoint. So one endpoint plus the net change would be where you end up. So here's the first example, and I've copied down this equation again because we're going to plug into that as we go. The initial population of a city is 2,500 people, and the population is changing at a rate of p prime of t people per year. Write an equation to represent the population of a town after 5 years. Okay, so what they've given us here is the initial population. Well, if that's the initial population, 2,500, haven't they really given us an ordered pair? So our initial population is 2,500. So since our function is p prime of t, p of 0 would be 2,500. And aren't they asking us to find the population after 5 years? So aren't they asking us to find p of 5? Well, if you think about this in terms of a definite integral, they have given us the rate of change as p prime of t, people per year. Your initial population, p of 0, would be my f of a. And so if I add the f of a plus the integral from a to b of the p prime of t, I would have the function that I'm looking for. So f of b, or the right side endpoint, or the endpoint after 5 years, p of 5, is equal to p of 0 plus the integral of that rate of change. So it's the integral from 0 to 5 of p prime of t dt. So this is the function that we're looking for. They gave us an endpoint. This is the net change from the beginning of the problem. If we add those two together, we will end up with the final answer at the end of the problem. In this one, there are 30 gallons of pollutant in a lake at t equals 0. So they've given us our initial value, or our initial condition. If the number of gallons, p of t, of the pollutant changes at the rate of p prime of t equals 1 minus 3e to the negative 0.3 square root of t gallons per day, where t is measured in days, write a definite integral expression to determine the amount of pollutant in the lake after 12 days. Okay, so they gave us the initial condition, 0, 30 is our first ordered pair. We're using p of t, so p of 0 equals 30. We know that this equation represents the rate of change, and they want us to determine the amount of pollutant in the lake after 12 days. So they want us to find p of 12. Well, that's one endpoint. This is the other endpoint. This is the rate of change. So we can use the formula f of b equals f of a plus the integral from a to b of f prime of x dx. If we plug in f of b, they want to know what it will be after 12 days, so that would be f of 12, or in this case we're using p because p was the function. So p of 12 equals f of a, well, that was your 0, so p of 0, which is 30, plus the integral from the start time to the finish time. Start time is 0, finish time is 12. So it goes from 0 to 12 of that function p prime of t. And one thing you need to know about the AP test is if they just ask you to express something like this, they are not going to require you to rewrite this part of the function. They are perfectly fine with you just writing p prime of t. So if you think that would save you some time, that is perfectly fine. You can do that and still earn all the points. And notice they didn't ask us to solve it. They just ask us to write the equation. So you're finished at this point. You can move on to the next one. Don't do anything extra on that AP test because you won't get credit for anything extra. Throughout the day, people have entered a craft fair at the rate of E of t equals 30t squared plus 16t people per hour and have exited at a rate given by L of t equals 12t minus 3 people per hour. If t is measured in hours since the fair opened, and there were 200 people at the fair at the end of the first hour, how many people should be at the fair 3 hours after it opened? So go ahead and pause the video, see if you can get this one on your own, and then I'll come back and work with you in just a minute. Okay, hopefully you've had time to try this one. This one's a little bit different, but I think it's good for you to try to think through a problem like this. We said that as long as we have one endpoint and then the rate of change, we have enough to figure out what the other endpoint is. One of the endpoints that they give us is that at the first hour, or after the first hour, there are 200 people at the fair. So that's an ordered pair. At hour 1, we have 200 people. So that's our starting point. That's what we had at the first or one end of where they're talking about with this problem. Now, they don't ask us to find how many people were there from the beginning or hour 0 to 3. All they ask for is how many are there at hour 3. So if we use 200 as the end point, so 200 is how many are there initially. We're saying we initially are starting this problem at hour 1. Then we're going to add to that the integral of the net change. Well, you have to think about that. If we started at 1, my A will be 1. We're ending it at the hour 3, so this will be 3. And then this part right here is a little bit different. They didn't just give us one equation for the rate of change. They gave us 2 of them. They said that people have entered the craft fair at a rate of this function, and then they are leaving at a rate given by this function. So if they're coming in at this rate and leaving at this rate, if we subtract those 2 from each other, we'll have how many are still there at hour 3. So 200 plus the integral from 1 to 3 of the people who are entering and exiting will give us the rate of change of people at the fair. And don't forget your dt, that is your variable of integration. Water is leaking from a tank at a rate of square root of t plus 1 gallons per minute. 10 minutes after the leak is discovered, there are 60 gallons of water in the tank. How much water was in the tank when the leak was initially discovered? So go ahead and pause the video, see if you can figure this one out, and then I'll come back with the answer in just a minute. This one is a little tricky because the way it's worded seems a little strange. We have the rate that the water is leaking out of the tank, and then it says 10 minutes after the leak is discovered, there are 60 gallons of water in the tank. And then they want to know how much water was in the tank when the leak initially was discovered. Well, if you think about this, there are 60 gallons of water in the tank 10 minutes after the leak is discovered. So if this is what's left after 10 minutes, couldn't we take what's left and add to it the amount that drained out over the first 10 minutes, 0 to 10? So that's what we're going to do here. And with this one, it does not say you can't use a calculator, so we're going to use a calculator for this one. We haven't really talked much about calculators with integrals yet, so I'm just going to show you real quickly on your Casio what buttons to push to do this. This is probably not the best way to do this, but if you go to, if you want to put an integral in your calculator, first of all, you're going to type in 60, and then 60 plus, and then to get an integral in there, you see these words down here, you want to click the button below the word math. So that is F4. You're going to click that. Then that gives you some more choices. You want to click the F6 for the over arrow button, and then you should see the integral button at F1 underneath, or it's above F1. So if you hit F1, it will then put that integral into your calculator. The cursor will be blinking at the blank for the equation, so you're going to put the equation in first. So that's the square root of x plus 1. Now, this problem says t plus 1, but we have to use x in the calculator. And then once I get that in there, I'm going to hit my up arrows, my up arrow button right here, and the cursor will be in the top where your b value is supposed to be. So we're going to put a 10 in there. And then I hit my down arrow button to get to where the a value is supposed to be. That was 0. And then I just hit the over arrow button and then hit execute, and it's going to solve it for me. I'm getting 83.655. We will always round things to 3 decimal places when we're doing this. So the answer to this one is 83.655, and how much water was in there, so that would be gallons. Sometimes they may be more specific and say round to the nearest gallon, something like that. You just have to read what they ask you to do and do what they say. A function is known to be increasing at a rate modeled by f prime of x equals 4x plus cosine x. It is known that at x equals 2, the function has a value of 25. Find the value of the function at x equals 12. You may use a calculator and round any decimal to 3 decimal places. So go ahead and pause the video, see if you can figure this one out, and then I'll come back with the answer in a few minutes. So here I have this one set up. They gave you that f of 2 is 25 and our b value is 12. They want us to find the value of f of 12. Remember, the function is f of b equals f of a plus the integral from a to b of f prime of x. So f of b would be f of 12 equals f of a was 2, so f of a is 25, plus the integral from a to b, 2 to 12, of the function 4x plus cosine x dx. I then put this in my calculator, and I rounded to 314.913. And the last one, a pool is leaking at a rate of v prime of t equals negative 25 pi over square root of 2t, where v is measured in gallons and t in days since the leak began. The pool held 5,000 gallons of water at t equals 3. How much water is in the pool after 5 days? So go ahead and pause the video, see if you can get this one, and I'll give you the answer in just a minute. So for this one, they gave us that v of 3 was 5,000. They wanted us to find v of 5. Here's our formula that we're plugging into. F of b, the endpoint, is equal to the left endpoint plus the integral from the left to the right endpoint of the rate of change. So v of 3, our left endpoint was 5,000 plus, now we don't have to go from 0 to 5. We don't have to go from where it started leaking. All we need to know is what it is at the endpoint they're asking us for. So if we know what it was at 3 and we know the rate of change, well, if we know what it was at 3, then all we have to do is figure out how much more it leaked from 3 to 5. So we add this to the 5,000 and we end up getting 4,944 gallons or 0.018. So it's about 4,944 gallons. And you can think about this. Does it seem reasonable? Well, it's leaking, so we know the amount in the pool is getting less. So yes, it would have worried me if this number was bigger than 5,000, because that would tell me we did something wrong. Is it feasible that after 2 more days we have, what would that be, 56 more gallons? Well, if it's leaking pretty quickly, then yeah, that could very well happen with a pool that size. So always think about the reasonableness of your answer. If it's not reasonable, make sure you go back and try to rethink it, try to do something different. That maybe a lot of times when I make a mistake, it's usually just a plus or a minus in the wrong place, something really simple. It could be a calculator error. I put something in wrong. So just be careful. Look at them, look at the reasonableness of your answers, and then go from there.